Hey everybody, this is Larry. This is day 23 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. 5 days till the marathon today. I just ran 4 miles easy. But man, everything feels weird. They say that tapering kind of brings everything, like, you just go a little bit crazy in tapering because your body's just used to so much stress that when you're just not stressed anymore, that like your body just have a lot of adrenaline and cortisol and all these things. So I don't know, so I'm feeling really tired. I don't know, it's just everything is just weird. I'm tired, but I can't sleep, stuff like this, right? So I don't know anymore, but that's good. So this week, I'm not gonna lie, so yeah, with this week my videos are terrible. My apologies. These are supposed to be, live through the good times and the bad times, and usually I'm pretty good, or like good enough for these, but man, these last couple of days I've been suffering. But let's take a look at today's problem. Let's go. We have 2641 cousins in binary tree 2. Given the root of a binary tree, replace the value of each node in a tree with the sum of all its cousins' values. 2 nodes of a binary tree are cousins if they have the same depth with different parents. Yeah, okay. Return the root of the modified tree. Okay. Sum of all the cousins, or of its cousins' value. Why is 4 not a cousin of 9? What's a cousin again? Oh, I guess because they're siblings. So 4 and 9 are siblings, but you want cousins. Okay, I mean that's not so bad, right? I think the hardest part about this one is just try to figure out how to represent, or think about how to just how to think about it, I suppose. But what I mean by that is that once you kind of rephrase the problem in a way that you can think about it clearly, then the implementation is not so bad. And for this, for example, what are cousins, right? Cousins are basically everyone on your level that isn't your sibling. And once you do that, then now you could represent that formatically, right? Like, it means everyone on that depth. So you take a sum of everyone in depth, which I think we did that problem yesterday, or similar enough problem, right? So we do it once, and then the second time we just look at its siblings, and then we should be good, right? Yeah. Yeah, and I think that's pretty much it. And you could do it like, I don't know if you could do it in quote unquote one pass. I mean, not that one pass matters, because these things are very, weird with respect to passes, because these are randomly accessed node ends, or these are like, the nodes are not in a contiguous chunk of memory, right? So 1 pass or 2 pass, does it really matter? I guess it kind of still does, but for cache efficiency, it does, it's out the window anyway. But okay, so then here we want to say we have a traverse function. I'm just so tired. Yeah, we have a node, and then we have a depth. We did this yesterday. We've just tried to figure out a sum of the depths, right? So level sums, maybe like this, right? And we just put it in. I think I actually did it with an array, and then I can do something like if depth is greater than or equal to length of level sums, then that means that we want to add an append of 0 to it, and then now we just do level sums dot append node, or not append, oops, of depth, we add it to node dot value, right? And of course we do it through node dot left, depth plus 1, traverse, node dot right, depth plus 1, right? And and this is pretty much it for with respect to just getting with respect to just just getting the level sums of all the levels, right? And then now we can traverse it again. I have to figure out how to name it. Maybe this could be like get sum or something, or like whatever. But traverse we want to just basically repopulate, right? So modify. I don't know. Naming stuff is hard, and today I am not good anyway. But yeah. So then here we can also even just say like siblings, right, or something like this, right? Siblings sum. And then now, and depth, of course. So then, and I did this yesterday too. I don't know why, but because usually this is the first thing I write, but today I don't know why I kind of forgot about it, and yesterday as well. Yeah. So then, if the node is not a node, then we go. Otherwise, then now we take the sibling sums, right? And then level sums at depth, we want to minus siblings sum, right? Yeah. And then now, node dot value is equal to this, and then we also traverse node dot left. We have to figure out what the sibling sum is. Traverse node dot right. Ooh, and also it's traverse modify, right? Oops. Right, so then we have these two things, and then yeah, and then you have to figure out what the new sibling sum is. But now you have this parents, right? So if you have this parents, then you can just say node dot left dot value plus node dot right dot value, kind of, right? Because of course, if you write it this way, node dot left could be none, and node dot right can be none. So this is probably not the way to write it, but the idea is there, though, right? So then now maybe new siblings sum is equal to 0. We have if node dot left is not none, then we sum it. And then we also do it to the right, and maybe you could have done this in a for loop as well, but you know. And that really should be it, right? Yeah. And then now and if you had used a sentinel root value, then you don't have to do anything funky. But you can also not do anything funky by sibling sum. In this case, would be just root dot value because it doesn't have the other sibling. But yeah. And then now we just return root again, and we should be good unless I'm wrong, of course. Oh no! Oh, level sum. Okay. Hopefully it's the typo and that's it. Am I Gucci? Yeah, okay, let's go for it. Let's see. Okay, yay! Yeah, good streak. We did this last year. It looks really slow, so I'm curious what makes it slow. Oh, I did the wait. I basically on the first pass. So on the first pass, I also sum up the children, so then you could look at the parents' children. Okay, that's smart actually. I mean, but you know, it's the same idea really, so it's not a big deal. But I don't know why it's that much slower. Maybe Leetcode upgraded some stuff or something. But yeah, this is gonna be linear time, linear space. Can avoid all of H space if you want to call it that. Can't really avoid it because that's the stack size. And of course, you have to look at each node at least once. In fact, we look at it a couple of times, but constant number of times, so it's overband. That's all I have for this one. I don't know why I'm so. I mean, I know why I'm so tired, but I planned it for this, and I'm still like way before. Like I planned it, knowing that I'll be tired this week, but it's tough some days. But that's all I have for now, though. So you know, let's keep going. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.